Okay, let's resume this seventh question of the paper. It says in the diagram OAB is a sector of a circle with radius 2r and angle AOB is pi by 6 radians. The point C is the midpoint of OA. Okay, and we have to um, we have to show that the exact length of BC is this. Okay, the exact length of B. Okay, so yes. Okay, guys, the exact length of BC. So I think you have to apply the cosine rule that you people have done in your O levels. Okay, so can I say I'm doing it's working here. This BC square is R square plus 2R square minus 2R into 2R into cos pi by 6. Okay, so this BC square is going to be this is r square plus 4r square, that is 5r square minus 4r square. Cos pi by 6 is, I think, under root 3 over 2. Now, this is really unfortunate. Some of the students simplify these two, like, they do write 5r square minus 4r square equal to r square, and ignoring that this r 4r square is being multiplied by under root 3 over 2. So guys, please be careful, okay? So this BC square is going to be, if you want, you can take r square common from here. This is 5r square minus 2 under root 3 r square. So if you take r square as common, this is going to be 5 minus, come on, yaar. Okay, this is 5 minus 2 under root 3. So if you take the square root, you get this BC as r into the square root of 5 minus 2 under root 3. So we have used that cosine rule over here. So please, you need to retain all your O-level mathematics. You have seen it here, okay? Now we go to the B part. It says find the exact perimeter of the shaded region. Exact perimeter of the shaded region. So we have already got this BC, and this length is going to be like, this radius is basically 2r over here. So this length is 2r. So this will be like using s equal to r theta. This would become 2r into pi by 6. So this would be pi r by 3. So the perimeter would be, let me write the perimeter here, okay? So this is going to be r plus pi r over under root 3, and then plus this r into the square root of this 5 minus 2 under root 3. You can keep it like this, or if you want, you can take r as common. R into 1 plus pi by under root 3 plus the square root of 5 minus 2 under root 3. Okay, so this has to be in terms of r. If you have r with you, you can find its numerical value. Okay.
Sir,
Yes.
सर ये पाई आर के नीचे अंडर रूट 3 कहाँ से आया है?
Just a minute. Just a minute. It says, yeah, this is. Oh, why did I write this under root? Yes, you're right. This was pi by 3. You're right, beta. This is just pi by 3. Why did I write this under root by? This is pi by 3. So that is the exact, perimeter of this shaded region, provided we don't have the R with us right now. Okay. So then it says C part, find the exact area of the shaded region. So I'm I'm wondering why saying Has he given us any value of r over here or not? Hmm. It is, yeah, it is in terms of R. Okay. So next it says the exact area of this shaded region. So guys, this is going to be area of the sector. Okay. Area of the sector minus area of this triangle. So let's do that. So part C's answer, I'll be doing the part C over here now. Let me cover this up. Okay. So part C, area. So a shaded area would be area of the sector minus area of the triangle. So area of the sector is going to be um, that is going to be half r square, and remember your r is 2r, half r square theta. Okay, minus, we can use that formula, half into AB sine theta. So half into R into 2R into sine of pi by 6. Okay, so I get this is half into 4 hours. देखो half को I'm writing quarter. Half into 4 r square into pi by 6, and this is cancelled by this, minus r square, and sine pi by 6 I know that is half. Okay, so let's take half r square common from here. So we have 4 pi by 6, that is 2 pi by 3 minus 1. That is the exact area in terms of R for this. Okay. Okay, so this was your seventh question. Can someone please check the answer? So here is the eighth question. It says the diagram shows part of the curve this, and there are some points given to us. The shaded region is bounded by the curve, the line y equal to 2 and the line x equal to 1. Find the volume generated when the shaded region is rotated through 360 degrees about the y-axis. Okay, you rarely find a question where you have to find the volume when you rotate the region about the y-axis. Okay, so this is the question here, and you see he has written this bold so that you like note it down. So this is basically, you have to be careful about, like, this, all this region is going to be rotated over here. Okay, and then you have the curve like this. Okay, so it would be like this, this, and this. Okay, it is rotated, beta. Okay, so guys, you have to excavate, take out this, like, the cylinder from the area, from the volume generated by rotating this shaded area about the y-axis. Okay, so choice is yours. You can use all the integration, or you can use the mensuration formulas over here. Okay, so the first thing over here is, let's do that step by step. First of all, you need to write your equation x in terms of y. So your x will be 6 over y. Secondly, you need to square this, that is 36 over y square, and I'll be writing it as 36 y raised to power minus 2 because I have to integrate it. Okay, so now the outer region is going to be greater, and the outer volume minus the volume of this cylinder. That is the plan with us. Okay, if you have any other plan, please let me know. So the volume, the required volume is going to be limit from, you have to use the limits on the y-axis from 2 to 6. This is pi limit from 2 to 6. We have already squared it. So this is 36 y raised per minus 2 dy, and then minus the volume of the cylinder. Let me write it as it is, volume of cylinder, which is, you can see that in this diagram, okay? So this is going to be, this is an easier integration. Let me keep this 36 pi out here. So this becomes the integral of y raised per minus 2 is going to be y raised per minus 1 over minus 1. So you can write it as minus 1 over y. So this is minus 1 over y, and limit from 2 to 6. Okay. Then the volume of cylinder, that is going to be 1 over 3 pi r square h. The radius is this x coordinate, that is going to be 1 square, and the height is going to be 4 over here. Okay, this is 6 minus 2, that is 4 pi r square h. Okay, so this is going to be
Sir, isn't it just pi r squared h?
pi r square h, 1 over 3 pi r square h. Yeah. Sorry. It is just, oh, thank you, beta. Thank you for this. I wrote that wrong here. That is a cone. Okay. Thank you very much for the corrections here. So this is minus 1 over 6 minus 1 over 2. And then you have minus 4 pi over here. Okay. So I have 36 pi into half minus 1 over 6. What is that? This is 3 minus 2 by 6. This is 1 by 3. 1 over 3. Okay. And then you have minus 4 pi. This is 12 pi minus 4 pi. And this is going to be 8 pi unit cube. Okay, that is the volume. Someone please keep on checking the answers, beta. I'm waiting for you to confirm the answer. Okay, we got the correct answer. Let's move on to its B part. The tangent to the curve at a point x is parallel to the line y plus 2x. Okay, let me note down the equation of this curve. That was y equal to 6 over x. Let me write it here. Y equal to 6 over x. Okay. It says the tangent to the curve at a point x is parallel to the line y plus 2x equal to 0. Show that x lies on the line y equal to 2x. Okay. The tangent to the curve. So without wasting any time, we need to have dy by dx. That is going to be minus 6 over x squared. Because if you write it as 6x squared minus 1, you can easily have the derivative, that is minus 6x squared minus 2. So that is the derivative here. Now at the point x, let me see if that point x is given to us. Point x, there is no point x. Okay, so is parallel to this y plus 2x. Now, this y plus 2x, that is equal to 0. This y is equal to minus 2x. This means the gradient of this tangent is minus 2. So we can put that equal to minus 2. So we have x square equal to 3. So your x is going to be plus minus under root 3. Okay. So if your x is, okay, this is your x over here. And then the tangent of the curve is parallel to the line this. Just hold on. Okay, so we got the x coordinate or the x coordinates of those tangents there. Okay. And then we put that x into this equation over here. I get it. Let me do that working again. So I get y equals 6 over. Acha, there's one thing that, you know, this diagram, if we refer to the diagram, this is towards the positive side of this, I mean, x is over here, okay? And it's just asking about one point, okay? There's a point x. So we'll assume that this point has to be the positive one, okay? So we'll say, okay, this x is going to be just under root 3. So let's put that under root 3 here. So this is going to be, we rationalize this. This is 6 over under root 3, under root 3, under root 3. So going to get this y equal to 6 under root 3 over 3. That gives you 2 under root 3. So it says show that x lies on the line y equal to 2x. So you see your x coordinate is under root 3 and your y coordinate is 2 under root 3. This justifies that y is equal to 2x, as 2 under root 3 is going to be 2 into under root 3. So that is justified. If you have any question, please let me know. I'm stopping for a minute here.